Hey there. When most people think of network design, they picture something like this, a complicated diagram filled with mysterious devices like firewalls, routers, switches. It looks like a giant puzzle. Now, figuring out where each pieces fit in can be very overwhelming. But what if I told you it does not have to be that complicated? Let's simplify this for you. Have you ever noticed how building a computer network is a lot like building a house? Now, stick with me and I'll show you understanding network design can be very straightforward as planning your dream house. First thing first, why do we need networks? See, think about why we build houses. We want a safe, comfortable space where everything is easily accessible. In the same way, network creates a connected environment for our devices. It allows computers, smartphones, printers, and other gadgets to communicate and share resources seamlessly. Now, without a network, our devices would be isolated in different rooms with no doors, no way to interact or share information. A well-designed network opens up those doors, making our digital lives more efficient and connected. Now let's talk about how a network functions. Imagine you're planning your house. You need to figure out each room connects where to the hallway and how many people will move around. In the networking, we're doing something similar with data. Data moves through the network like people move through hallways or in the house. We use devices like routers and switches and direct the traffic to the right places. Let's break this down. Switches are layer 2 devices. Think of them as rooms and doors with a single family home. They allow members of the same family or devices within the same network to talk to each other directly. A switch handles the traffic within the local area network or the LAN. Routers are layer 3 devices. They are like your street connecting different houses, a neighborhood. Routers help different families or different networks communicate with each other. They direct data between multiple networks, ensuring you can reach the correct destination. Now, by planning out the layout, deciding where the switches and the routers go, we ensure that data can flow smoothly and every device gets the connectivity it requires. Now, what are computer networks really made up of? Finally, let's get into what do we need to build this network house. So first of all, let's start with connectivity, the WAN. Before the internet reaches your home or office, it travels over different types of connections like MPLS, Ethernet, wavelength services. Now think of these as various roads or highways, bridges, tunnels that brings all the essential utilities to your property's doorstep. Modem, another common piece of hardware. The modem is like your main gate of your house. It takes the internet from your service provider and connects it into a signal of your house that you can use. Router, as I mentioned already, it's a layer 3 device, is like a main road connecting to your neighborhood. It directs the internet traffic between the different networks, allowing different families to communicate. Firewalls, think of firewalls as your security system. It is going to monitor all the incoming and the outgoing traffic, keeping the unwanted guest out and allowing the safe data to pass through. Now switches, as layer 2 devices, switches are like rooms and doorways where your home is there. They connect multiple devices within the same network, allowing the family members to communicate directly. Cables and Wi-Fi access points, these are wire and wireless pathways. Ethernet cables are like your electrical wiring. It's very direct and reliable. Wi-Fi access points are like your wireless light switches, convenient and flexible. Finally, all the gadgets. The computer, printers, the smart TVs are the appliances and the furniture that makes your home. Now, real-world examples of network design. Let's explore how different houses or networks are built based on specific needs. Example 1, a small office. Imagine a small office that needs to connect a few computers, printers, and perhaps some smartphones. Now, internet connection and a firewall, that's all they need. The office uses an internet service with a firewall device that has few LAN ports and a inbuilt Wi-Fi. A very simple setup. This is like a cozy bungalow where everything is on one level and each room is easily accessible. Now, with this setup, everyone can access the internet securely, share files, and print documents without any hassle. Example 2 could be an enterprise office with 300 employees. Picture a bustling multi-floor office building that has 300 employees, Wi-Fi access points placed strategically on each floor to provide strong wireless coverage. Access switches per floor. These are like your electrical panels on each floor connecting all these devices and APs back. Your distribution switches that are in pairs. They are aggregating all the access switches, ensuring the data gets to where it needs efficiently. Dual firewalls in high availability. Two firewalls work together to prevent downtime, like having two security guards always on duty. Dual internet connections, connected to dual internet service providers for making sure redundancy and ensuring constant connectivity. This network is designed for high performance and reliability. Example 3, warehouse. Finally, let's get considering a large warehouse. A similar setup to the enterprise, it uses APs, switches, and firewalls. APs placement will vary in this case. Since it's a vast area with few users, APs are placed to maximize coverage over density. Cable runs and Ethernet limits. In a large warehouse, access points might be far from the switches. Ethernet cable have a limit of 100 meters, about 320 feet. So we need to plan for this by adding additional switches closer to the APs. Now, fiber optic connections. To connect these distant switches back to the distribution switch, we use the fiber optic cables, which can cover longer distances without any signal loss. Think of that as if you're extending your home wiring to reach, let's say, a detached garage. You'll need a special wiring to cover this distance without losing any power. Similarly, in a warehouse, fiber cables act like high-capacity highways that bridge the gap over long distances. Building a network doesn't have to be complicated. Start with your purpose, the why. Maybe you want seamless internet access for a small team, support hundreds of employees across multi-floor, or cover a large area like a warehouse. So figure out how to make it happen. Plan your network layout like how would you plan a floor plan? Decide where the wired connections are necessary, where the Wi-Fi is suffice. Consider redundancy for critical components to ensure reliability. In large places, plan for cable runs and the limitation of Ethernet cables using fiber optics where needed. Then list out what you need. Gather the right equipment, the modems, the routers, firewalls, switches, cables, access points, fiber optics, and set them according to a plan. Just like constructing a house, network design is all about creating a space that fits your needs. By understanding the purpose, planning the layout, and selecting the right components, you can build a network that is robust, efficient, and tailored just for you. So next time you see a complex network diagram, remember it all starts with basics. With a clear understanding, you can fit in all the pieces together without any headache. So thanks for joining me on this journey. Introduction to basics of network design. Remember, every great network starts with a solid foundation and a clear plan, just like your dream home. Bye for now.